Hi guys, it's Professor Walker Wall, and again we are going to be talking about significant figures. But today we're going to do addition and subtraction. That's the one thing that has been a problem for students over the years. So I really want to emphasize that today in our YouTube car videos. Now let me stress this again, do not put this on the dash. Because you will get a ticket while you're driving. As I said before, I almost got one, so don't do that. Moving right along, note, they are totally different from the multiplication and the division rules. Those are very straightforward. Just choose the least number of sig figs. But when you are doing addition and subtraction, don't think about sig figs until the problem is complete. Did you hear me? Don't even begin to think about significant figures until the problem is complete. So let's go through it. My students love methods, so here goes our little simple methods. So I'm going to start off with very, very simple problem, and at the end we're going to learn how to put the numbers in the same power of 10, because you know I love those kinds of problems. Moving right along. So step one. I want you to put all numbers in the same power of 10. So don't forget, if it's 10 to the 0, that's the same thing as 1, and you don't need to show that. And then I want you to line up the decimal points. That's going to make it very, very easy for you to see. Step number 2. After you perform the operation, you do your addition or your subtraction, then I want you to report your answer with the same number of digits after the decimal point. That means DADPs. My students came up with that. So let's say it again. Digits after the decimal point, as the number in the operation that has the least number of digits after the decimal point. So I'm not even talking about sig figs, am I? I'm talking about what? Digits after the decimal point, because that gives you your precision, and that's what this is all about. And finally, after this, after the whole thing is complete, all of the resulting numbers are significant. So we have to make sure that we understand what I'm saying. Let's look at this. An example, and I want you to think this in your mind. 20.0 plus 2. Now in your math class, you would say 22.0, wouldn't you? 22.0. Well, that will be wrong in chemistry. Why? Because how many digits after the decimal point do you have in 22.0? That's one digit after the decimal point. But when you add it to 2, there are no digits after the decimal point. So your answer can only have what? No digits after the decimal point. So what you have to report to me is 20 dot. Or you can say 2.0 times 10 to the 1. Okay? So I need to have 2 sig figs. So it's a whole different kind of thing, because when you think of 20.0 plus 2, you are thinking 20.0. Oh, that's 3 sig figs. 2 is 1 sig fig. So I'm going to present only 1 sig fig. No, that is multiplication and division. So again, think it out. 20.0 plus 2. Only 0 digits after the decimal point. So it would be 20 dot. And that dot signifies that that ending 0 is significant. So the answer in scientific notation would be 2.0 times 10 to the 1. All right, let's go to the board and let's talk about putting numbers in the same power of 10. Okay, now let's do some examples with changing powers of 10. Remember, if the decimal portion goes up, then the power 10 goes down, and vice versa, okay? So as one goes up, the other goes down. As one goes down, the other goes up. Okay, next. Now changing the powers of 10, let's do an example. I've got 8.2 times 10 to the third. And I want you to make this 10 to the fourth. Now, what are you doing with the power of 10? You are actually doing what? Making the power of 10 go up by a magnitude of 1, which means that the decimal portion must do what? Go down by a magnitude of 1. So you have to bounce that ball over 1 time. So the resulting answer would be what? I'm old, so do the 0 point in the front. Okay, guys? 8.2 times 10 to the fourth. All right, let's try another one. Now, the next one is the one that gives everybody hell. When I change those powers of 10 and I make them negative. Okay, so let's try something. So when you look at something like 5.9 times 10 to the minus 3, and now this time I want you to change it to 10 to the minus 4. Now I want you to analyze this. Is minus 3 larger or smaller than minus 4? It's larger. So you want to go down by a magnitude of 1 to get to 10 to the minus 4, which means the power of 10 must go what? Up by a magnitude of 1. So you bounce the ball over 1 time to make the decimal portion larger by a magnitude of 1. So the resulting answer is 59 times 10 to the minus 4. Does that make sense? I hope so. Now let's do some addition and subtraction. When you're doing addition and subtraction, you must first put all numbers in the same power of 10. If you don't put them in the same power of 10, you're not lining up your decimal points, and that is critical. So let's do an example. 6.0 times 10 to the third plus 5.0 times 10 to the fourth. Let's make that prettier. I need to make that prettier. All right. I don't care which power of 10 you put it in. Just remember, when you get to the scientific notation, you're going to get the same number. So I'm going to start off by putting them both in 10 to the third because it's up there. So 6.0 times 10 to the third. I don't have to do anything with that. But this decimal portion I have to change. What must I do? I have to make the power 10 smaller by a magnitude of 1, which means that the decimal portion must go up by a magnitude of 1. So that means I bounce the ball over 1 time to the right to make it larger. So when I put that in over here in our example, line up those decimal points, it's going to make a big difference times 10 to the third. So when you add this, remember how we add and subtract. We just bring down our powers of 10, and then we just do our little addition. That's not a problem. But we must be concerned about what? Digits after the decimal point. So when you're looking at your digits after the decimal point, here I have 1 digit after the decimal point. Here I have 0 digits after the decimal point. So my answer must have what? 0 digits after the decimal point. Now I'm old, so I need to see the line in the box so I can see exactly what's going on. So to put this into scientific notation, where do I have to bounce that ball? Let's write it in exponential notation first. I'll erase that. 56 times 10 to the third. So if I want to put this into scientific notation, the decimal portion, I have to then do what? Make it smaller by a magnitude of 1, which means that the power 10 has to do what? Go up by a magnitude of 1. So in scientific notation, this is 5 0.6 times 10 to the fourth. All right? Now let's try it a different way. Let's put them both in 10 to the third and see what we get. All right, so that means that the power of 10 goes up by a magnitude of 1, which means that the decimal portion, goes down by a magnitude of 1, which means I bounce it over one time. So when we put them both in the same power of 10, this will be 0.60 times 10 to the fourth. I didn't change this, so I can just write that in and just say 5.0. Oh my gosh! Oh my gosh! Oh look, it's coming out to be the same darn thing. 5.6 times 10 to the fourth. Genius! Thank you very much.